Today we are going to be continuing with Learning Target 1 from Unit 5. I can verify congruency through a sequence of translations, rotations, and reflections. So previously when we had talked about translations, we had compared them to sliding a figure from one location to another. When we talk about reflections, it's very similar to flipping a figure from one location to another. So in order to reflect a pre-image, we need to be sure that we take that pre-image and we are going to reflect that image across a line of reflection, and we need to make sure that those two figures are equidistant from that line of reflection. And equidistant just means that the two figures have to be an equal distance from that line that we are reflecting across. So if we look at example 1, it is asking me to reflect figure PQRS over the x-axis. So the x-axis, as we know, is the horizontal line across our coordinate grid. So if I need to make sure that my pre-image is equidistant from that line, when I'm doing my reflections, I'm going to choose one point to start. So in this circumstance, I'll choose S. My pre-image S is currently 1, 2, 3, 4, 5 units above the x-axis, which means that my reflection of S is going to be 5 units below the x-axis. So I will put my reflection of S there and label it using my tick marks. I will then continue to do that for every other point. So point R is 1 unit away from the x-axis, so therefore the image of R is going to be 1 unit below the x-axis. Point Q, pre-image Q, is 1 unit above the x-axis. Therefore, the image of Q will be 1 unit below the x-axis. And point P is 3 units above the x-axis, so the image of P will be 3 units below the x-axis. And once I make sure I label my points using my proper tick marks, I will connect the dots and get a congruent reflection of figure PQRS. Now, if I want to look at my points, I know that my original point P was at -2, 3. My original Q, my pre-image Q, was at -2, 1. R was at -3, 1. And S was at -3, 5. And if I look at my new values, my images of those points, my image of P is now at -2, -3. The image of Q is at -2, -1. The image of R is at -3, -1. And the image of S is at -3, -5. We are going to come back and analyze those changes in just a moment, but right now let's move on to 1B. So in example 1B, it's asking us to reflect that same figure over the y-axis, which is the horizontal axis through our coordinate grid. So I'm going to follow the same process. However, this time I'm going to be looking at how far away are my pre-image points from the y-axis. So my point S, my pre-image S, is 1, 2, 3 units to the left of the y-axis, which means that my image of S is going to be 3 units to the right of my y-axis. and I will label that my image of S. I will then do that same process with my point R, pre-image R. It is 3 units away from the y-axis on the left, so the image of R will be 3 units to the right of the y-axis. For Q, the pre-image Q is 2 units to the left of the y-axis, so the image of Q would be 2 units to the right of the y-axis. And P is 2 units to the left of the y-axis, so the image of P will be 2 units to the right of the y-axis. And again, be sure that you are labeling your points with your tick marks so you can remember which is your pre-image and which is your image. So if we record these points, again, pre-image PQRS has the exact same points that it did in our previous example. However, if we look at the points of the images of P, and this is actually our second image, so we will add 2 tick marks. So if we look at the second image of P, your new point is at 2, 3. The second image of Q is at 2, 1. The second image of R is at 3, 1. And the second image of S is at 3, 5. So if we go back to example 1a, and let's analyze what happened with these points. So if I look from the pre-image P to the image P, I notice that my x coordinates are the exact same for every single point. So I would infer that when I am reflecting over the x-axis, the x value stays the same and the y value flips to the opposite sign. If I compare when I did my reflection over the y-axis, I look at my y values are the same in both the pre-image points and the image points. So I can infer when I reflect across the y-axis, the y stays the same, and the x-coordinate flips signs to the opposite. So to generalize that, if I start with an ordered pair of x, y, if I reflect across the x-axis, the x stays the same, and the y becomes the opposite sign of what it originally was. If I reflect across the y-axis, the y stays the same, and the x changes to the opposite of what it previously had been. And while we haven't done an example yet, if we reflect across both the x and y axis, so if I take my pre-image, I reflect it over the x-axis, and then take that new image and reflect that over the y-axis, that is going to make both values change to the opposite of what they were. So if they were both positive, they'd become both negative. If they were both negative, they would become both positive. So continuing to example 2, describe the reflection that maps triangle QRS to the image of triangle QRS. So again, we have to identify which is the pre-image and which is the image. Looking at the ordered pair, at the labels on the grid, I see that my upper left-hand corner has a R with no tick mark, and the lower right-hand corner has an R with a tick mark, which means that my upper left-hand corner is going to be my pre-image, and the lower right corner is going to be my image. So looking at my pre-image, I need to think ahead a little bit. If I were going to reflect across the y-axis, that would put my triangle into this quadrant right here, quadrant 1. However, my figure is not in that quadrant. So then I might think, all right, if it didn't reflect across the y-axis, then it must reflect across the x-axis. Well, if I look at my pre-image, if I were to reflect it across the x-axis, it would be in this third quadrant here, which again, it is not. So this is going to be an example of a multiple reflection or multiple step reflection. So how am I going to get my pre-image into that image spot? I can see that maybe it was reflected across the y-axis and then reflected across the x-axis, or it was reflected across the x-axis and then reflected across the y-axis. Regardless of what the order was, our verbal description would be that triangle QRS was reflected across both the x and y axis. So again, order does not matter with those kinds of questions. That will eventually matter once we start doing multiple transformations in one example. However, since these are both reflections, the order does not matter. Now, sometimes the line of reflection will cut through a figure. So if we look at example 3, we're asked to reflect across or over the x-axis. Well, the x-axis cuts through triangle JKL. Regardless of whether the line of reflection is through a figure or not, we are going to follow the same steps. So I'm going to look at point J, which is at 1, 3, and I'm going to see how far is point J above the line of reflection, above the x-axis. And if I count, 1, 2, 3, it's 3 units above the x-axis, so my image of J will be 3 units below the x-axis at 1, negative 3. If I then go to reflect point L across the x-axis, L is 2 units below the x-axis, so the image of L will be 2 units above the x-axis. So L, which was at 1, negative 2, will now be at 1, 2. And then K, 2 units below the x-axis, so the image of K will be 2 units above the x-axis. So a point, our pre-image that was at 3, negative 2, our image will now be at 3, 2. And we should notice again that our pre-image and image are congruent. They are the exact same figure, just flipped or reflected. Now our last example sometimes gets a little confusing. sometimes the line of reflection is not the x or the y-axis. It's another line completely. So for example 4, it says, reflect the following over the line x equals 1. Well, x equals 1 here, x equals 1 here, x equals 1 here, here, x equals 1 anywhere along the vertical line through the point x equals 1. So that is going to be our line of reflection. I'm going to follow the exact same steps, however, I'm going to be counting my units to the line x equals 1 as opposed to the x or y axis. So if I look at point A, pre-image A is at 3, 4. If I want to reflect that across the line x equals 1, I'm going to see A is 2 units to the right of x equals 1. So the image of A will be 2 units to the left at -1, 4. Point B is 1 unit to the right, so the image of B would be 1 unit to the left. And point B was originally at 2, 2. It is now at 0, 2. And point C, which is at 5, 1, is 1, 2, 3, 4 units away from the line x equals 1. So 1, 2, 3, 4. It will be 4 units to the left. And that is our image of C. So we will go ahead and connect those points. We see we have two congruent triangles, and our image of C is at -3, 1. Now, one main thing that I have to make sure that we understand before we go is that when you are reflecting over a line that is not the x or the y axis, the general rules that we talked about on our previous page, the general rules right here, do not apply. So do not make the mistake of trying to use those rules from before when you are reflecting over a line that is not the x or the y axis. Okay, that concludes our lesson for today. One thing I do want to clarify on your homework, if you look down at number 3, you're going to be reflecting that figure over the x-axis, and then you're going to take the new figure, that image of wxyz, and you're going to reflect that new figure over the y-axis. So it's a combination of reflections, as opposed to taking the original, reflecting it over the x-axis, and then taking the original again and reflecting over the y-axis. All right, that concludes my lesson. Thanks, guys. Bye.